past 2 days. Ty did all her problems using that long, drawn-out way where we put everything in prime factor form, and then she figured out her answers. That is great. Ty is not getting penalized for not using this shortcut. What I challenge Ty to do, and what I'll challenge you to do, is if you're trying to get bonus out of me, so that worksheet, John David has this right here, it had 30 problems on it, right? Ty could get 30 bonus points from me if she went back and worked them all out a different way. So if she did everything prime, with the prime factors, she could go back and do everything with the way we were talking about yesterday. Or,
You said that only works with square.
it does, but I could give her quite a few problems. You're right, so she wouldn't get quite 30. She'd probably get, but most of them were, half of them were. She'd get like 45 out of me. 45 out of 30, that could raise your grade probably about 3 points, if I guessed. That's me guessing. It honestly depends on how bad your grade is at this exact moment as to how much good it could do. I would make sure it did some good there. But I understood Natalia's cry to me yesterday of, so do I need to go back and do all of them using this way? My answer is no. Natalia can finish that old worksheet doing the exact way she wants to, and that's fine. But on this worksheet, when she finally does turn it in to me, which is not going to be right this exact second, so she doesn't need to flip out yet, when she does turn this one into me, she's not going to have that old school prime factor form way. Because Natalia just pointed out the obvious. We can only use our cheats when it's perfect squares, or at least that's what I said. That's not true. We're going to debunk that too. But notice this whole entire worksheet is perfect squares. So using our little perfect squares card, I'm going to do some of the harder ones. Notice this says that there are 41 of them. Look how fast we're about to do this, John David. So I'm going to go around the room, and each person's going to help me do one of them, and then you're only going to have the others left. It's going to be great. Okay, John David, you're up first. John David, what perfect square, I need a big one, that goes into 40? If anyone helps John David, I promise you I will find more worksheets. Don't help John David right now. What is the largest perfect square? Use your little note card. 4? Is that what you said, John David? 40? What goes into 40? 4 and what? 4 times 10? 4 times 10. What does that end up reducing to? John David only. Okay, you give him a divorce. I'm out of room. You give him a divorce, so it's square root of 4, square root of 10. What is the square root of 4, John David? 2, and then what is left over? So, okay, under the, what's its real name? Not the house. Okay, square root, but what's the R word we've been using? Oh, thank you. Good gravy, whoever helped him with that. Thank you for that. Okay, I want, let's see. I want Ty to help me with we're going to do number 33. Number 33. Can you help me with 33, Ty?
9.
That's the answer? No, why is that?
Because 9 is a perfect square.
9 is a perfect square?
Yeah.
9's not a perfect square.
81.
81 is a perfect square. And what is the square root of 81?
9.
Okay. So that one's really easy. You said it wrong. You said 9 was a perfect square. That's not true. Not true.
I said 9.
Yeah, it broke my heart too. Okay. Rex, number 30, largest perfect square that's going into 75. I know you know that. Largest perfect square that's going to go into 75. Don't say things out loud. Although, yes. No,
That's a question.
I can't answer it. Let me talk to Rex first, and then I'll answer your question. Largest perfect square. You have your list of perfect squares.
I think it's opposite. Like, I'm thinking it's the number.
You have a list of perfect squares. I'm trying to figure out which one of these divides nicely into 75. Which one of my yellow numbers? I only need Rex. You can all put your hand down. I'm going to wait on Rex. If you're that bored, go do the other easy ones while he talks to me. Is it 9? Is it 49? Is it 36? Is it 25? Okay, so what should I do? Do you want me to save you for a different one? I didn't hear you. Okay. Katie, you're about to bust. I'll let you do this one.
Okay, 25 and 3.
25 times 3, and what does that end up reducing to? Keep going.
Oh, 25 and 3. Divorce.
Okay, they got a divorce. Now what's my final answer?
25 and 9.
What's the square root of 25, Katie?
Oh, 5.
And then what's left over?
3.
So 5 square roots of 3. Okay, so let's see. Yes, dear, you had a question.
I said 9 is a perfect square, but 9 isn't.
Oh, yeah, 9 is a perfect square, but that's not the largest one that goes into it. Oh, yeah, I'm sorry. I'm just not catching up to our old conversation. You're right. My bad. I'll let it go. I'll let myself go on that one. My bad, Ty. I was in another world. Okay, let's see. Let's see. Let's do Kiana, number 32. It says square root of 80. I need a big perfect square. This one's hard. Well, I know like 8 times 10, but I know those are perfect squares. So you said 8. Which one of the perfect squares kind of is similar to, has a lot in common with 8? I think you already know what number, so check with your calculator and see if you can figure it out. I don't need your help. I do love you, though. Just go on to a different one, John David.
If the thing is, I know the answer.
Which one do you think it is? Josh, don't help her. Okay, so 80 was 8 and 10. I agree. What else multiplies to get me 80? There have to be other things. What else goes into 80 that you know of? What? You know 5 goes into it. Probably, but then that's probably not the biggest. So why don't you see, does 5 go into it nicely? We assume, yeah. So what's left over? Oh, my goodness. Okay, so we got, what was it?
Wouldn't it be just, the 4 square root,
Yes, yes. Okay, so Kiana got there, she said at 16 and 5, so she even went straight to the final answer. She didn't give him a divorce, she didn't pass go, she just said it's 4 square roots of 5. I'm happy with that. In fact, if Kiana doesn't even want to show me her work and just wants to give me all the answers, that's fine. But if I find out that Kiana just asked her calculator and her calculator is giving me the answers, you know eventually I'm going to tell. Certain ones can, yes.
How did you get 4? Because it's 4 square root of 16.
The square root of 16 is 4. We gave him a divorce. It's square root of 16, square root of 5. I know the square root of 16 is 4, so it's 4 square root of 5. She's just not writing that step. She did it in her head. Okay. No, Kiana. Okay, I am growing weary, so I'm going to, I know Tiffany and, well, I don't know. Is there anyone else in Katie, is there anyone else who wants to try it one?
Oh, I got this.
You want to try it
I want
one?
to try one.
Okay, everyone wants to try one. Okay, so number 36, Josh.
Number 36.
36.
There it is. Okay, so 90.
Mm-hmm.
9 is 9 times 10.
Okay, 9 times 10, and what do you end up getting?
90. Yeah, 90.
I get that. What's my
Or you
final
get a
answer
divorce.
when I reduce it? Okay, I gave him a divorce, and then what's my final answer?
It's going to be 3, and then 3 square roots.
Perfect.
Wait,
Okay.
Is that the short way?
Is this my short way?
No, I'm talking, is this like that short way that we just on this?
This is exactly what we were doing yesterday. This is exactly what we were doing yesterday.
What if I switch?
Exactly what we're doing
Like if I
yesterday.
made it 10 times 9 instead of 9 times 10?
That's fine. It's just I like to put the radical at the end, and I know the piece that's not the perfect square is going to end up with the radical. So that's why no.
I just made it, but the long way so easy.
Okay, so let's see, and I'm going to pick on poor Kaylee because she wasn't even here yesterday, but I'm pretty sure she can do this. Number 40, 99. What times what is 99? Is one of those a perfect square? 9 times 11, and then give him a divorce, and what would my final answer be?
3 in the outer box, and then 11 into the
Okay, 3 square roots of 11 is correct. Does anyone else need me to continue to work these, or do you have it down?
Keep on working.
Oh yeah, let me just keep on working this whole worksheet. Okay.
You said everyone has to do one.
I did say that. You know what? I'm about to make you do the whole thing, but you already knew all that. You knew that was coming. Oh my, you knew that was coming from me. Okay. I want you to stop on that one and get out the old one for a second. I do just for a second. Just for a second. Just for a second. Just for a second. The old one from 2 days ago. You have it. The tiny squares. Yeah, the one with 1,000 boxes. Yes. Yes, that one. So I was supposed to make this one due today. Yeah, I heard that. I know you were supposed to turn that one in today, because let's face it, we spent like 5,000 days on it. I'm not gonna make it due today. It is not gonna be due today. Because instead, like Josh is only 3 away, I'm gonna make it due, let's say Tuesday? Because you're bad at Monday due date, so we'll make the exponent thing due Monday and this due Tuesday. But I want to, the exponent thing, the heart. Yes, the heart's due Monday, this is due Tuesday. In fact, instead of it, I would work on this one because it's way more fun. But before we go crazy and work on that one, I do want to add something to our note cards, and I'm going to use this one to help me out. Okay, it was, hey, I don't know. Someone asked me, it was Josh, because Josh and I had this whole discussion about other Josh. He asked me this whole discussion. Okay, let's look at, for instance, I'm specifically wanting to look at, Josh, weren't we talking about number 11? I want to look at number 11. What is different about number 11? Why can we not use our new rules on number 11? The radical is 3.
No.
The radical is 3. What is that called?
Index.
Index is 3. Okay, so it didn't work because we didn't know, like our perfect squares don't work with that. So what would work with an index of 3? How could we we could make a cheat sheet for 3s with cubes. Excuse me. So the next thing I'm going to add, and you should have some room, is perfect cubes. She's right. So does Ty actually have to list out in prime factor form in order to figure out the answers? No. If she knows her perfect cubes, she can do any with an index of 3. She can break them up the way we've been breaking down the squares. So for instance, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. Don't ask me why I know those. I guess I've just done enough problems. I think 6, I don't know 6 cubed. 7 cubed I think is 243. I need to ask my calculator, honestly. I need 6. I know, the cubes, no. 6 cubed, 36 times 6, 196? Is 6 cubed 196? 216. And then 7 cubed is at 243? 343. See, I knew I was close. And then 8 cubed, and then it stopped showing off now. 512, and then 9 cubed. 725, and then 729. That makes so much more sense. And then 10 cubed. 1,000. I bet we all knew that one. Now, let's face it. In fact, did you notice Miss Compton only knew up to 5 cubed? We're probably not going to use 6 through 10 cubed. But hey, they're on our index card, and maybe they could be useful. So now that we know our cubes, let's look back at some of the ones on our worksheet. So for instance, if we look at number 13, or even number 11 like I was wanting, I want to know a perfect cube that divides evenly into 16. Which one of my perfect cubes? So it's either going to be, I could circle, is it 8, 1, 27, 64, 125? Those are going to be the most useful. The 8, 27, 64, 125 are most useful. 8 goes into 16? How many times? Okay, so it's going to end up being 2 cube root 2. Because they got a divorce, so it would be cube root of 8, cube root of 2. If they got a divorce. And we figured out the cube root of 8 already on our index card. That is 2. So it's 2 cube root 2.
You have to keep the.
You have to keep the index of 3 next to that one that's left over, yes. Because if you don't, then we're going to think the index has changed to 2.
I don't like that.
Yeah, me neither.
Well, I can't change math for you, dears. Even if I wanted to.
That way's still too hard.
Okay, so, and notice the same thing's going to happen on number 12. So let's look at number 12. It says cube root of 40. So I need to know a perfect cube that divides nicely into 40.
Still ain't.
It's still 8. It's still 8. So when I give them a divorce, cube root 8, that is 2. Cube root 5. So it's 2 cube root 5. No, not at all.
Wait.
Really no.
So we knew it was 8 times 5,
8 times 5 is 40.
because 8 times 5 is 40. She got 8 from our list of perfect cubes. So she knows if she takes the cube root of 8, she's going to get 2. They got a divorce, so cube root 8, cube root 5. I know the cube root of 8 is 2. I don't know the cube root of 5. I'm just going to write cube root 5.
For the cube root of 5 is 125.
No.
The cube root of 125 is 5. Is 5 one of the perfect cube numbers we have? No.
Oh,
Okay, so yes, dear.
Why do you put the 2 outside the house?
Because the cube root of 8 is 2. So if I had to, you know how we could rewrite this as 8 raised to the 1/3, or you could type that in your calculator. It's going to tell you the answer is 2, because 2 to the 3rd is 8. So the cube root of 8 is 2. Okay, so if I found one more like this, it's probably going to end up being darn 80. And no, it's not. I'm going to pick a different one. I wanted 14, but I'll do 13 for you. And then I'll do 14. So 13, it says cube root of 135. How can I break down that 135? What are my perfect cubes that I could use?
120.
125 does not divide nicely into 135.
Oh, I don't get it.
Which of my cube roots? It's probably going to be 8, 27, or 64.
27.
27 times what?
5.
Okay, so 27 times 5 is 135. If I give them a divorce, I'll have cube root of 27, cube root of 5. I know the cube root of 27, that's 3, so it's 3 cube roots of 5.
This makes sense.
I know, we just needed a few more days on it. Okay, and then if we did number 14, and do not help Ty. Ty, looking at our list of cube roots, what cube root goes nicely into 243? It's over on my desk somewhere, Ayana. In that silver tray, I believe. Look at our list of perfect cubes. So it's going to be either 8, 27, 64, or 125. Those are the ones I circled because those are the ones I use the most. I don't think so.
She didn't ask for this.
I still don't get it.
Which of these numbers? 8, 27, 64, 125.
Random number doing it.
No. You pick one of these.
Don't help.
We pick one of these. Okay, Ty. We made this list of perfect cubes, right? You understood how we use the list of perfect squares, right? You're good with it. We were looking for those multiples. Yes? We're looking for one of these. And the ones I didn't circle are a little too big. They don't come up a lot, and I don't know what problems we're working. So we're probably wanting to know if our number, which happens to be 243, is it divisible by 8, 27, 64, or 125? It's probably goes evenly into, one of these numbers goes evenly into 243. So does 243 divided by 8 give you a pretty number? Does 243 divided by 27 give you a pretty number?
Yes.
What did it give you? Okay, so cube root 27 times 9. I give them a divorce, so I have cube root 27, cube root of 9. Do we know the cube root of 27?
Yes.
What is it?
3.
3. Do we know the cube root of 9?
3. Wait, no.
No, so it's 3 cube root 9. I know you wanted to say something else, but it's not squares, it's cubes. Does that help?
It does.
Now, if we wanted to be show-offs, and since we do have extra room on our index card, I'm not going to do it because you need to practice on your own some, but we could, for the fourth roots, go back and do all the ones that were to the fourth. Do 1, 4, 2, 4 through the fourth, and notice there'll be a pattern with those two.
They call it fourth.
Yeah, to the fourth. There's no fancy name for them. So that would be smart, because if Natalia's getting to use this little index card on her test, Natalia already knows what numbers she should be typing in her calculator. She sees a cubed problem, why don't I try dividing by 8, 27, 64, 125. If I see a squared problem, I'm going to try those numbers and something in yellow.
You want to try the fourth?
It would be, I'm telling you, you probably get to use your cards. If you want it on your card, that's for you.